Hello everyone, welcome to RN Tutorials. In this video, we are going to discuss about moment of inertia of triangle, how to derive an equation for moment of inertia of triangle. Okay, so here we all know about the moment of inertia equation for the triangle, which is about the center of gravity as bh³ by 36, and similarly about its base, it is equal to bh³ by 12. We know the formula, but how to derive this equation we should know. So in this equation we will be using theorem of parallel axis theorem of parallel axis for deriving this. So step by step, now I would like to explain how to derive this equation, that is the moment of inertia of triangle about its center of gravity, which is bh³ by 36. Okay, so first we need to consider a triangle which is of ABC. So assume this is triangle, assume a particular triangle that is ABC, and assume the size as base as B, okay, which is width we can consider, and the height as small h, which is the height of the triangle. Okay, and again for deriving the equation for the moment of inertia of this whole triangle, first we need to consider an elemental strip. Okay, a small elemental strip in this triangle ABC. So first consider an elemental strip PQ as shown in figure PQ, which is at a distance of small x and from the vertex A. So which is at a distance of small x from the vertex A, and which is of thickness having dx. So assume the distance is x from the vertex and it is having particular thickness dx. Okay, so now we try to write the moment of inertia for this particular small elemental strip, so that we can find out the moment of inertia of whole member, which is the triangle here. So first we have to write moment of inertia of this substrip PQ about the base BC. So with respect to the base BC here, we are writing the moment of inertia for this particular PQ here. Okay, so how to write means already we know the basic formula, which is perpendicular distance square into area of particular figure, for which we are going to find out the moment of inertia. So for this PQ, what is the perpendicular distance from this BC we have to know, and the area of this PQ we have to know. So the perpendicular distance is total height of the triangle is h, and the distance of this PQ from vertex A is x. So the perpendicular distance from BC becomes h minus x. From the figure we can analyze the perpendicular distance from BC to the PQ is h minus x. So we can write the moment of inertia as perpendicular distance square, which is h minus x whole square into area as dA we can write. Okay, so in this again, what is the area of this elemental strip we have to know. So this area, before that assume this equation as 1 as a reference. Okay, so the first equation is h minus x whole square into dA, which is the moment of inertia of only a small elemental strip we have assumed, that is PQ. Okay, so now we try to write what is the area of this PQ. So dA is equal to, we can write it as, so little bit we can consider this PQ as a rectangle, okay, which is the smaller size, so that we can assume this PQ strip as a rectangle. So the rectangle formula we know, that is length into breadth. So length is PQ and the breadth, that is the thickness, is dx we can assume. So assume this equation as 2 again. So in this equation 2 again we need to find out what is PQ, what is the length of this rectangle, that is the elemental strip PQ we need to find. So for finding that we need to consider geometrically similar triangles. So what are the geometrically similar triangles here? ABC and APQ. So from the geometrically similar triangles of ABC and APQ, we can write a particular equation. So in the geometry of similar triangles, while studying the geometry, we have derived the equation. Okay, so that equation is, we can write it as PQ by BC. So these two parallel sides PQ by BC can be written as x minus h. Okay, now with respect to this PQ strip, which is parallel to the BC, the distances we need to consider x by h, the ratio of x by h. This is the derived equations which can be studied in geometry. Okay, so that geometrically similar triangles for ABC and APQ, we can write it as PQ by BC is equal to x by h. Okay, so again BC, what is the BC here? From the figure BC already we have assumed as a B, which is the breadth of the base length of the triangle here. So PQ by B is equal to, we can write it as x by h. So finally PQ we need to find out. So the PQ can be written as Bx by h. So this equation we need to substitute in equation 2. in which we will be writing the area of this elemental strip. That we have written the equation 2 as dA is equal to PQ into dx. So in place of PQ, try to write it as bx by h into dx. Okay, next again we need to substitute this dA equation in 1, which is the moment of inertia of elemental strip. Again I will show you the equation. The moment of inertia of elemental strip PQ about BC is equal to h minus x whole square. So in this equation we need to substitute dA value. This dA value we need to substitute here, which is the equation 1. So try to substitute. Okay, these are the two steps. We have gone to the next slide. So in this slide I have shown same what is the dA formula, and we need to substitute this dA in in equation 1. So the moment of inertia of this strip about BC is h minus x whole square into dA. So in place of dA we are going to write this equation we got. So write h minus x whole square into dA as bx by h into dx. Okay, so this is the moment of inertia of only elemental strip PQ. So for getting the moment of inertia of whole triangle, we need to apply the integration with the limits of equal to 0 to height. Okay, 0 to equal to the height, we need to apply the limits. By integrating the equation we will be getting the moment of inertia of the whole figure. Okay, so now we try to write moment of inertia of whole triangle is obtained by applying limits 0 to h during the integration. So that IBC, that is the moment of inertia of this triangle about its base BC, can be written as integration 0 to h, as it is the formula we got for the moment of inertia of elemental strip. Okay, so that h minus x whole square into bx by h into dx. Okay, next we go to the next slide with the same equation. So this is the same equation. So in this again we need to elaborate h minus x whole square, and by taking the b by h as common, take the b by h as common. So now apply the same integral and then elaborate this h minus x whole square as a minus b whole square. So h square plus x square minus 2hx into, as it is, we will be having x into dx. So in the next step try to take the x into the brackets. Okay, so as it is b by h integral 0 to h, now take the x into the inside of the brackets. So we can write it as h square x plus x cube minus 2hx square. So when it comes to the x inside, h square x will be getting, and x into x square x cube, and 2hx into x will be getting 2hx square into dx. So now try to derive each and every term in the brackets which are in multiplier of x. So with respect to x only we need to integrate. Okay, so b by h of h square integration of x, will be x square by 2, x power n plus 1 by n plus 1, which will give you x square by 2. So that we will be getting h square x square by 2, plus similarly integration of x cube is x power 4 by 4, which is again x power n plus 1 by n plus 1, the formula. So x power 4 by 4 we can write, and similarly minus 2hx into x cube by 3. Okay, so by integration we'll be getting this one, and again we need to apply the 0 to h limits. So 0 to h limits means we need to substitute this h value in all x places minus and zeros in all x places. So when you apply 0, total term will be becoming 0, but when you apply h, the terms will be getting in terms of h only. Here all the terms will be in terms of h. So finally we can write the equation as b by h of, so h square into, in place of x we need to write h, again h square into h square becomes h power 4 by 2, and similarly when you write in place of x as h, then it will become h power 4 by 4, and minus 2hx cube means h cube into h becomes again 2h power 4 by 3. Okay, so by applying the h, by applying the limits into this equation we will be getting the equation like this. Now we can take the h power 4 as common. So take the h power 4 as common, b by h into h power 4. So when you observe this, one h will be cancelled in the denominator and numerator. So finally we will be getting the terms as 1 by 2 plus 1 by 4 minus 2 by 3. These are the terms we will be getting. So we go to the next slide with the same equation. Okay, now we need to modify these terms 1 by 2, 1 by 4 and 2 by 3. Okay, so by taking the LCM we can modify. So bh cube of, the LCM of 2, 4, 3 is 12. Okay, so when you multiply this 12 to the 1 by 2, automatically you will be getting 6. So 6 into 1 becomes 6, plus, and again 1 by 4 into 12 will give you 3. So when you multiply that 3 with 1, so automatically 3, and again 2 by 3 into 12 3 4 ja and 4 into 2 8 it will give you, so minus 8. Okay, so when you modify this again, subtract and add, so again it will be 6 plus 3 9, 9 minus 8 1, so 1 by 12 will be getting, finally we will be getting the equation as bhq by 12. So this is the moment of inertia of the triangle with respect to bc of its size, that is bc. Okay, so now we need to find the moment of inertia with respect to the center of gravity. So that center of gravity, how to find out means we need to take the help of theorem of parallel axis. So from the theorem of parallel axis, moment of inertia about the parallel axis, which is here BC, that can be written as IBC is equal to IG plus AD square. So this is the moment of inertia with respect to G, which we need to find out, and area into the distance from the parallel axis to the center of gravity of the figure whole square we need to consider. This d square, d value is the distance of the center of gravity of this triangle from the parallel axis, means this is the BC parallel axis. So in this equation we need to find IG. So IG is equal to, we need to write it as IBC. Sorry, here it is showing AB. Sorry, it is showing AB here. Consider BC. So IBC minus AD square. So now we try to write IBC. IBC already we got it as BHQ by 12 minus area. Area of the triangle is already we know half BH. So that is BH by 2, we can write it as, and the perpendicular distance. Okay, perpendicular distance means distance between the BC and the center of gravity. For triangle, the distance between the base and the center of gravity is equal to 3 times of, sorry, h by 3. H by 3 is the formula which we need to remember. That is the distance of the center of gravity from its base for the triangle. So h by 3 whole square we need to write. Okay, so when you modify again this equation, bh cube by 12 minus bh cube by 18 will be getting. So again take the LCM of 12 and 18 will begin take, so before that take the bh cube as common. So when you take the bh cube as common, we can write it as 1 by 12 minus 1 by 18. So when you take the LCM, automatically it will be equal to 36. So when you take the 36, 12 into 36, it will give you 3, and minus similarly 1 by 18 into 36, which will give you 2. Okay, so 3 minus 2 by 36 will be getting by applying the LCM condition. So 3 minus t is 1, so finally we will be getting bhq by 36. So the moment of inertia over the center of gravity for the triangle is bhq by 36. So remember, moment of inertia of triangle with respect to its base is bhq by 12, and the moment of inertia of moment of inertia of triangle with respect to the center of gravity is bhq by 36. Okay, this is the way of deriving the equation for the moment of inertia of the triangle with respect to its center of gravity as well as with respect to its base BC. I hope you understand. So remember the values for solving the problems. In the next video, we'll try to solve some simple problems on moment of inertia for the triangle. And once again, thanks for watching my video. Thank you all.